Woohoo! We are back. We're in 6.5 and we just bought a house. And you are happily living in this house paying $4,026.16 every month. And you've been doing so. Time is going to pass. Doodle-doo, doodle-doo, doodle-doo. Now we are now 10 years in the future. So 10 years in the future. You've made payments for 10 years and would like to know how much you still owe on the loan. Why would you want that? Well, you could want to refinance. So in other words, you get a new loan at a different interest rate with different terms, perhaps a lower interest rate. Perhaps you want to know how much you still owe because you want to figure out whether it's worth selling the house, comparing how much you could get for selling it with how much you would still have to pay the bank back. And you're thinking, I've been paying for 10 years. Now, 10 years is a full third of a mortgage, right? It's 1/3 of 30 years. So you probably have a ton of it paid off, right? Dun, dun, dun. Okay, so let's go ahead and use this formula. Now, what I'd like to do is I'm going to take us back in the Wayback Machine and remind you of the formula from 6.4 that looked like this. That was the present value, so how much it's worth right now, of an ordinary annuity, which is what a mortgage is. A mortgage is an ordinary annuity, as long as we're, depending on when the pay date is, and we're being a little, fudgy about that for right now to keep things simple. But in an ordinary annuity, we can figure out how much it's worth right now. So what is the amount of the loan still outstanding by calculating this. Now we're going to use this formula, but we're going to change it slightly. A equals RR, yes. I's in the denominator, woohoo. 1 minus 1 minus 1 plus I. The only difference here is that this is going to be minus N minus K. That exponent is going to be the opposite of the quantity N minus K. And N minus K is simply the number of payments left. So this is not intended to be, super, mysterious. It's just literally saying you need to count up how many of the payments are left. So let's look here at this problem. We've made payments for 10 years. So in order to calculate this, we're going to go ahead and say, okay, we paid for 10 years, which is 10 times 12, which is 120 payments. So we've paid for 120 payments. We need to know how many are left. Number of payments left is N minus K. This right here is going to be our K, how many have already happened. So we had a total of 360. We subtract the 120 right there, and we get 240 payments left. So to find our payoff amount, or to find how much is left on the loan, we're going to go ahead and calculate the present value, what it's worth right now, of these 240 payments that are going to come in the future. Because basically, you're going to make a deal with the bank and you're going to say, perhaps, I would like to get out of this loan. And they'll say, well, you still owe us all these payments, so we're going to work out what that's worth to us right now. How much money you'd have to give us now to make it worth the same amount as that. So that's what we're going to work on. And so in this case, A is the one we don't know. We do not know what it's worth right now. We do know what the payments are because we worked them out before. They're on this lovely sheet over here. So let me remind you, the payment was $4,026.16. $4,026.16. Now, There is a little bit of fudging here because this is a rounded number. Remember, we talked about that last time. So there are 240 payments, but that last payment isn't quite equal to this, but we're not going to worry about it here. That's the great thing about math, is we can say, this is the way we're going to do it. And then in accounting, you may have a slightly more fancy, slightly more sophisticated way to actually work it out. And I'm going to leave it to them to go over that, you know, in your finance classes, your MBA program, all that fun stuff. For right now, we're just going to say, you know what? That's our payment. We got 240 of those. Let's do it. The other thing we need to know is our I. Now, that is the interest rate that we used for the original loan. So in the original loan, remember, it was 5% monthly. So we had that 0.05 over 12. Okay, so my A is equal to 4026.16 times the quantity, 1 minus 1 plus 0.05 over 12 to the negative 240. That's, oops, sorry about that. That was exciting. That's how many payments are left. That's what goes right there. Oh, you know what? I already had it in yellow. I don't know why. I guess I got excited. It gets two colors. It's yellow and blue, just because we're so excited. Imagine you're new homeowners, you're very excited, you've made 10 years of payments, you figure, wow, I've made quite an investment. And then this is all over 0.05 over 12. Now this one, I'm not going to write out explicitly how to calculate it. I'll just show you. But definitely, if you have any questions, ask. Okay, let me show you in the video though, hopefully. Okay, so I'm going to start off. Let's see, is there a good way to do this? Maybe I can squish this. Squish you up there. There we go. I'm sorry. I'm going to ask my support animal to support me from the sidelines, so I got a little more room. And then let's go ahead. So I'm going to start 4026.16. Some people multiply this last. You're welcome to do that. I'm going to go, as I usually do, across the top and then divide by the denominator. So parenthesis, 1 minus parenthesis, 1 plus 0.05 divided by 12. I'm going to close this parenthesis and then use my exponent key. And again, for my calculator, I'm going to press the change the sign button first and then to 240. Yours might require you to switch that order, the 240, and then change the sign. Then I'm going to move myself back out of the exponent, close my parenthesis, and hit enter, and get that. Now that's just this numerator part, this times this, and now I'm going to divide by 0.05 divided by 12. Oops. Let me try that again. 0.05 divided by 12, parentheses, fingers crossed, and that amount is incredibly disappointing. 610,065.1544. And some other stuff it's not telling us. So let's reflect. How much is still due? $610,065, and I'm going to round down to 15 cents. Technically speaking, there may be cases where we'd have to do something more interesting because this is technically underpaying. They're missing by half a cent. So different banks may have different standards and ways they would approach this. But this is what is still owed. So now what? Well, when we think about what happened, let's look back. We took out a loan for $750,000. As you can tell, my cat is very, very interested in home financing. He's actually going for his license, for his brokerage license, believe it or not. It's hard without opposable thumbs, but he has very strong feelings about interest rates and about fixed loans versus adjustable, as most cats do. We took out our original loan for $750,000. We paid for 10 years out of 30. You paid for a third of the loan, and you still owe over $600,000. You've only paid off 1/5 of the loan amount. And that's what happens when you take out a mortgage. It's something to know when you take out long-term investments like that. If you take out long-term loans, the interest is substantial. And remember, when we talked about how much it was going to take to pay off the whole thing, we were actually going to have to pay almost double the amount to pay off the loan. So the fact that 10 years in, we've only paid off about 1/5 of the loan, not surprising. And that's why I wanted to do this problem, just in case you ever are fortunate enough to be able to buy a piece of property. If you'd like to do that, know that mortgages pay off very, very slowly. So in the beginning, you're mostly paying interest. But eventually, you do pay off the whole thing. By the end of the 30 years, you've paid the entire investment. Woohoo! Or entire loan amount. Okay, let's go on. Dun, dun, dun. Number 4 in the book. I'm always fascinated by whether the book gives people names or not. The book decided to give this company a name. 4 years ago, Ben&Core decided to expand its production capacity and borrowed $1.3 million for 20 years at 5.2% compounded quarterly. Oh my gosh, that's a lot. After making 16 quarterly payments and it tells you how much the payments are. That is awesome. So we don't have to calculate the payments. It's going to calculate the payments for us. Ben&Core is considering refinancing this loan for 15 years at 4.8% compounded quarterly, with refinancing charges of $5,000 added to the amount of the new refinanced loan. Okay, so a lot is happening here, right? Let's talk it through. And I'm realizing I didn't leave myself a lot of room here, but let's see if we can make the best of it. Okay, let me squish this over a little bit. So first, we want to find the payoff amount of the original loan. So let's look at the original loan. Now, the original loan, there's stuff that we need and there's stuff that we don't need. We know that the original loan was for $1.3 million. So $1.3 million. Okay. We know that the time was going to be, which I think, let's see, time was, I think 20 years. And our interest rate, our annual interest rate was 5.2%. So that means that the number of payments, now what was our M? Let's go in and look. We've got 1.3 million, 20 years at 5.2%. I wrote down all of that, and it's compounded quarterly. So here, when we say it's compounded quarterly, we're going to say M is 4. Quarterly means 4 times a year. Okay. So that tells us that our total number of payments is 20 times 4, or 80 payments. So originally it was going to be 80 payments, and I is going to be 0.052 over 4. And then we are grateful in this case because that actually works out nicely evenly. So we can go ahead and say the interest rate per period is 0.013 per quarter. Also, we know that our payment amount is $26,235.37. Why is it so high? Well, it's so high because they're only paying quarterly. They're not paying monthly. So they have to pay off their loan in big chunks. If they were paying monthly, you could imagine this would be considerably less. Okay, so that's the original loan. Right now, they've got that payment. They've paid 16 quarter payments. So that means out of the 80 payments, they've got 64 left. Does that make sense? So if they paid 16 of the payments, then 80 payments total minus 16 is 64 payments left. And so what we want to find out is how much is outstanding, how much is due right now. Oops. Oh my gosh, is there a pterodactyl behind you? Right behind you. No? Okay, never mind. Sorry. I thought it was a pterodactyl. You can look back at the screen now. So how much of the loan is unpaid? How much do they still have to pay back? Well, I'm going to use this payoff amount formula. I'm going to use this one right here. I don't know. Let's see. Can I get that on the screen so that we can see it at the same time we're filling it in? Let's see. Did we do it? Squish this up a little bit. Yes, we can. Yay, look at that. Okay, so we're going to use the payoff amount from the previous page. We're going to say the payoff amount is our payment. Now, the original payments, so that's $26,235.37. And then we multiply times the quantity 1 minus 1 plus 0.013. Now, the exponent, remember, is to the opposite of the number of payments that are left. So that's going to be negative 64. And the whole thing's going to be over 0.013. And we are grateful, as I scooch this over a little bit, we are grateful that this is a nice decimal. It's really behaving well because we could divide out and get an exact value. If this were like the previous problem, we would have to leave the fractions in for the I, for the interest rate per period. Okay. Hopefully you're feeling really confident about this now because we're doing the same calculation over and over and over again. 26235.37 times, and again, I'm going to go across the top, quantity 1 minus quantity 1 plus 0.013, close up. Now, obviously, for this 1 plus 0.013, you could just write it as 1.013 if you want. Go for it. I'm going to do my exponent key. I'm going to do my change the sign key. I'm going to do my 64, and I'm going to hit enter. And you notice I even skipped the last parenthesis, and it was like, that's fine. Okay, so that's my numerator, and then I have to divide that whole thing by 0.013, and the answer is 1135148.823. Put in some commas, and then we're like, oh man, we've made 16 of the payments, right? So in other words, we've paid off for 4 years and barely made a dent in the what the present value is of the loan, right? So the payoff amount of the loan is almost the entire loan. And again, this always happens when you make these large, long-term mortgages or loans like this. You're going to end up where in the beginning of the loan, you don't pay it off very quickly. You pay it off mostly at the end of the loan. The beginning of the loan is mostly interest. Okay, so this is the outstanding amount, which we can go ahead and estimate to be $1,135,148.82. There we go. Woohoo! Okay, so that's how much they have to pay the bank to get out of their current loan. That's how much they still owe on that loan. Okay, that's fine. Now what we want to do is we want to find the amount of the new loan and the new quarterly payment. Okay, so the new loan. Now, keep in mind, they don't have to take out a loan for 1.3 million because they've already paid some of that out. For the new loan, they're going to have to pay back this amount, the amount they still owe. So A equals $1,135,148.82. But there's a complication. In order to get my blue, actually green, we do green so it's more visible. In order to take out this loan, they're going to have to pay some fees. So we're going to have to add the 5,000. And a lot of times, if you take out a loan, more often on a house, so more often a mortgage, but if there are extra fees, there are extra costs, they'll say they'll roll it into the loan. So instead of you having to pay it right out of your pocket, then they just make it part of the loan. So I don't trust myself right now. 1135,148.82 plus 5,000. Let me show you right there. Equals, and it's not surprising if you add 5,000, $1,140,148.82. Okay, so that's our new loan amount if we want to change loans. Okay, and then for the new loan, we've got this A, this present value, this amount we want to borrow, and now the interest rate. What is the benefit of the new loan? Well, the new loan is going to be 4.8%, so slight reduction in the percentage. Now, what are we really looking at? Well, will we save enough money going from 5.2% to 4.8% to compensate for the extra $5,000 cost? So that's what we're trying to weigh. Is that 0.4% interest worth spending $5,000 on? Let's see. So our new our new interest rate will be 4.8%, which is 0.048. So our I, again, this is also going to be compounded quarterly, so I can underline that with yellow too. These are both loans are going to be quarterly. So we're going to get 0.048 all over 4. Underline here. I'll also underline here just in case you missed that. And that's actually going to work out really nicely. Yay! Because it goes into it evenly. Yay, yes! Okay, so that's our new interest rate per period. Now the term on this, how many years? It's going to be 15-year loan. It's also going to be quarterly. So our N is going to be 15 times 4. We're going to have 60 payments left. Now, this is interesting. We're going to be paying this back faster than, so on this one, we had 64 payments left, which is going to be a 16 years left. And here we're going to try to get it over within 15 years. So our monthly payment, even though our interest rate is going down, our monthly payment may actually go up because we're trying to pay it off faster. So these are all things to consider. Okay, so now for this formula, we want to go, do I even have it here next to me? Yes! No! I don't think I do. So you're going to have to, there we go. There we go. I think I have it right here. The amortization formula, we're going to use this formula to find the new loan, right? We want to find R, we know A. A is this, here's our I, here's our N. And so let me see if I can scooch this down at the bottom so you can see them both at the same time. Okay, so our quarterly payment is going to be A. So it's this new A amount, 1,140,148.82 times the quantity. And remember, for this one, when we're solving for our payment, we actually have I on top by itself. So 0.012 all over 1 minus 1 plus 0.012 to the negative. And again, this is how many we want to pay. We want to pay this over 60 periods. Okay, so far so good. Let me go in and calculate. I've already got this in my calculator. Good reason not to just always hit clear. I'm going to multiply across the top as I... Oh no, it got tired of me. It was like, I just done waiting for you. I've got better things to do. I'm going to multiply across the top, 0.012. And then I'm going to divide by, and a bunch of parentheses now, 1 minus, another parentheses, 1 plus 0.012, close parentheses, exponent, negative 60. Again, make sure you use that. Bring it down, close the parentheses. And our new payment is going to be $26,766 and then 29938, which means we're going to round this guy, $26,766.30. And again, since we're rounding up, that means that we're going to pay it, but our last payment will probably be slightly smaller because we will have slightly overpaid every month by a teensy a bit. Okay, this is our new payment. You guys are awesome for sticking with it. I know this is a lot. Look at all this math. You guys are amazing for keeping up with this. So the next and last question. Woohoo, we are almost done. Woohoo, this is so exciting. Should they refinance? And as we look at it, I mean, you could make the case that no, they shouldn't. You could make the case that, look, this is how much they're currently paying per month, and this is their new payment. And you could say, wait a minute, that's a whack ton. That's like $500, over $500 extra per quarter. That's some money. So you could say, we can't make this switch because we can't afford that increased payment. Okay, that's one possibility. Another way to answer it is to say, okay, well, the original loan, we had 64 payments left at $26,235.37. And so that would have been a total of 64 times 26,235.37. And we'll see that the old loan, we still had $1,679,063.68 to pay. This is the total in the future payments. So this is not the value now, but just the total over the lifespan. And the new loan, well, the new loan will have 60. Remember, we're tightening that up. We're not going to owe for as long. We're only going to pay for 60 quarters times that new payment, $26,766.30. And when we multiply that, 60 times 26,766.30, that is going to be a total of $1,605,978. So if we look at it, from this perspective, the original loan, this is how much we're going to end up paying back. The new loan, this is how much we're going to end up paying back. So over this time, if we switch to the new loan, the total of our future payments means that we'd be saving almost $75,000. The new loan is going to be a lot less expensive over time. So I think personally the answer is yes. The new loan will save the company and then I am running out of room. Okay, if we take 1,679,063.68 and we subtract 1,605,978, we get $73,085.68. So even with the extra $5,000 in fees, we're still saving the company $73,000 over the life of the loan. And so I think the answer is yes. But again, you could debate this. You could say, well, but it is an extra $500 a quarter, and maybe you don't have that. So maybe it's not worth it. The other way you could look at it is 60 quarters is 15 years, and 73,000 divided by 15 is about 5,000. So you'd be saving about $5,000 a year and paying an extra $500 a quarter. So that would probably make the case to your board of trustees. And with that, you guys are done with chapter 6. Yay! You guys are awesome. Thank your support, Carnivore. Thank your support, people. Go out, get hydrated, get a little exercise, eat some vegetables, go find some sunshine or rain, get outside in some fresh air, and know that you are amazing and incredible. And I am so proud of you for making it through. And, just generally woohoo and math on.